Today I will demonstrate how to simplify radicals that contain negatives underneath the radical. When there is a negative underneath the radical sign, it just adds one extra step, and it's a fairly simple step. All you need to do is make sure that you pull out an I, because a negative underneath the square root means that it will be an imaginary number. So for the first problem, we have the square root of negative 108. So since I see a negative sign there, the first thing I'm going to do is I'm going to rewrite this as the square root of 108i. The next stuff is everything you learned in algebra. You're just going to simplify this so that you find your pairs, and whatever pairs you don't find, you leave underneath the radical. 108, two numbers that multiply to give me 108 are 12 and 9. Two numbers that multiply to give me 12 are 3 and 4. Two numbers that multiply to give me 4 are 2 and 2. I can't break 3 down anymore. Two numbers that multiply to give me 9 are 3 and 3. So once you have all your numbers factored out, meaning that all the numbers left are prime numbers that you can no longer break down, then you could go ahead and try and find your pairs. So I notice that I have these two as a pair, and I have these two as a pair. So since they found their pairs, they're able to leave the radical. So I'm going to bring a 2 out, and I'm also going to bring that 3 out. Unfortunately, this 3 right here did not find a match, so that has to stay underneath the radical. And I can't forget about that I that I pulled out at the beginning. And I also have to bring that I down. The last thing you'll do is you'll multiply your two pairs that you pulled out. So 2 times 3 will give me 6 root 3I. And that would be your final answer. For B, it's a little bit different because now we have a rational expression involved, meaning that there's a fraction. So we have the square root of negative 49 plus the square root of 64, all divided by 2. When you see a problem like this, the first thing that you're going to want to do is you're going to want to separate it so they're each under their own denominator. So we have negative 49 over 2 plus square root 64 over 2. I know that 49 is a perfect square. 7 times 7 gives me 49. I also see that there is an I there. So a negative there, so that means I have to pull out an I. So the first thing that I will do is I'll rewrite this so that it's square root 49I over 2 plus square root 64 over 2. Square root of 49, like I said, is 7 times 7, so it's just 7I. Square root sign goes away. Square root of 64 is 8. You could break it down, but if you know your perfect squares, it makes stuff easier. So I have 8 over 2. 7 over 2, I can't simplify, so I will just leave it like so. But 8 over 2 simplifies to 4. So I'm going to have 7 over 2I plus 4, and this would be my final answer. The last one that we're going to look at is just a bunch of numbers being added together. Currently, none of them are like terms, so I can't combine anything. But I could go ahead, try and simplify, and then see if I could break stuff down. So 7 is just a number. I'm just going to keep that down there. Minus square root of negative 17. So the first thing I notice is that there's a negative under the radical, so I need to pull out that I. So I'm going to have square root 17I plus square root of 25, I know is 5. So plus 5. Now looking back at the square root of 17, there are not any two numbers that multiply to 17 because 17 is a prime number. So the last final step in this problem that I would do is I would recognize that I have like terms, 7 and 5. 7 plus 5 is 12, And then I just have to make sure I add back on 17i. And that right there would be your final answer.